Hello everyone, welcome to day 16 of competitive programming challenge. Uh, let's open CodeChef and also start our timer and then continue solving the two questions which we have not solved yesterday. I think those are from the contest status 79. Here it is, and it's in div 3. Let's close this. We have solved listing suppositions, add smallest prime factor. Actually, we are getting TLE for this question, right? So let's open this atom prime fact. Okay, how do we reduce its time complexity? Well, here we can remove this prime function, and what we can say is we can rewrite that function together. Like basically that numbers will be divisible by prime numbers. If they are not divisible, it means that the number itself is a prime number. So we'll say int n, and I will write if the number is divisible by 2, then we'll return 2. Okay. Then we'll start, if it is not divisible by 2, then we'll start from 3, and we'll say, like for example, if given some number like say 14, now 14 lies between 4 square, right? Sorry, 5 square. So for this number, okay, it is an even number, so 15. So here we'll go with the approach where we'll take the prime number and we'll check it if the square of that number, if square of that prime number is less than n, then we'll check the naivety whether it is divisible by any numbers from it or not. It's more like smallest divisor. Okay, that means here if that square is less than n, then we'll increase it by plus equal to 2, so that if it is divisible, then we'll return as I as the smallest prime, or we'll return n itself as a prime number. So for any number like 15, we got 15. Since 15 is not a even number, then we'll go with 3. It is divisible by 3. We go for 16. It's even 17. 17 itself is prime. So this function will 3 into 3. Since the square is not less than n, then we'll go with 17 itself. So here we reduce its time complexity, and then here if it is not even, we'll add it. If it is even, we'll just add 2, and we'll go on increasing, and we'll just print the answer instead of having a while. Okay, we need to have a while loop, I guess. Shall we run it right now? Compile prime fact. And let's take all the values and paste here. We got level 5, 46 and 42. Yeah, the only thing we have done to reduce the time complexity is we have just written our finding prime factor method in a different way. Waiting for the test cases to start. Yeah, we are running test case 2, 3. Still we are getting time limit exceeded. So we need to try for another way also. Okay, here if it is divisible, if it is even, just will just increase, will add we'll just break. Instead of adding, we'll just break. After break, that means only for one time it will run this while loop, and we'll say answer plus equal to, we'll take the absolute value of the y value which we are reading, the number of ends. Basically, to get that we'll need to do y minus x plus 1 by 2. Here we'll get the absolute value. I guess that's it. By the way, to understand this question, you need to understand what we have done in the previous question. So please do watch yesterday's question. I mean yesterday's 1 hour of competitive programming. Currently running test case 1, 3. Yeah, now it's correct answer. So basically we have done two things to reduce the time complexity. One is to reduce this prime, finding the prime numbers, and other is the while loop. Well, once you find the prime number, that's enough. Next time you need to just break. I guess we need not even write the loop also. Isn't it right? What if after adding also the number is not prime? Will that be possible? No, that's not possible, right? So we have removed our file loop and we got compilation error. Why? G++ prime fact else break. Okay, we cannot have break, right? Break can only used inside 12, 5, 46 and 43. Okay, what is the while loop doing here? Will not directly add. If only if it is lesser we will add. Okay, that makes sense. Okay, now we got our correct answer. It is actually solved. But let's end this. We have done it in 10 minutes. Let's end this in with the correct answer. Yeah. Next we have 1 stone or 2 stones. Okay, we have read the question yesterday, and I guess we tried to solve it by using a while loop and if else. But let's read the question one more time. I guess we need not have t variables. Let's remove all the logic also. Because we were getting wrong answer, right? So that's why I guess we are getting wrong answer there. Anyways, let's see the question here. Chef and Chefina are playing a game. There are two piles numbered 1 and 2. Pile 1 contains X stones, while pile 2 contains Y stones. Chef starts the game. Okay. In each turn, Chef can either remove one stone from each from both the piles or remove two stones from pile 1. On the other hand, Chefina in her turn can either remove one stone each from both the piles or remove two stones from pile 2. The player who cannot make a move loses. Determine the winner if both players play optimally. Okay, first line contains T, the number of test cases, then we are reading X and Y. Initial numbers. And here the value is given at 10.9, so we cannot, even here we cannot solve this question in order of n time complexity. So I'm thinking for the approach we need to go for this. We cannot take the while loop because X and values are at 10.9. I am thinking let's turn this solution into simple FS where the time complexity will be only order of 1. So the point is, let's guess if x is equals to y. That is one case. Okay. Okay. And we'll find which pile is having more number of that means int difference is equals to absolute value of x minus y. Okay, we'll find the difference in each thing, and if what we gonna say, that is one case. And what are the other cases? We have 2 and 2, that means equal case, 1 and 10 and 4 and 2. So we'll have even or odd cases, I guess. So if x percentage divided by 2 not equal to 0 and else like it is equal to 0, right? And similarly for y also. So we'll take if if else y percentage by 2 not equal to 0. So first let's finish if x is equals to y. Since our chef is the one who is starting first, so let's take the numbers as 4 and or 2 and 2. So first removes 1, chef removes 1 and 1, so it becomes 1 and 1. Chefina will remove those ones, then it becomes 0, 0. And chef can't remove anything. So chef is a loser because he cannot perform the task. Okay, if you take 4, then chef is the one. Okay, 4 will be going for all numbers because if he is the one. If we go for 5, then it's a different scenario. So initially if they're equal, and if equal, and if x is even. Now only in that case x is even. In that case we'll print Chef is a winner with new line, and we'll return. Okay, else we'll say cout Chefina is the winner. Okay, here the codes aren't they are closed properly. Okay, here Chefina is the winner, and we'll return. That's it, right? And after finding the difference, if okay, we need to have also have difference is greater than 2. Even if it is equal to 2 also we can subtract 2, right? So 2 well, here I guess if difference is greater than 2, we need to find which element is great. X is greater than y, then chef will win automatically. Chef will be winning because since x is greater, he can subtract 2 from the x, but Chefina can't do that. And we'll write the exact similar opposite case. Okay, it's not if else, it's else if. So we'll say else if difference is greater than or equal to 2 and y is greater than x, then Chefina can win. Okay, and we'll return after printing. We shouldn't forget to return after printing. Okay, that's what we have done with these things. So let's compare. Even though the rating is 1500, I feel it's easy. Okay, for 2 and 2 we got Chef, but we need to get Chefina. Both are equal and x is divided by 2 equal to 0. Okay, if x is not equal to 0, then Chef will win. If it is equal to 0, then Chefina will win. My bad, sorry. Let's copy all these things. Let's paste here. Now Chefina, and Chef is winning. Let's submit. Currently try running test case 0. Okay, it's wrong answer. Only 2 answers are correct and 2 of them are wrong. Okay, there may be scenarios which we are not considering. For us, the given in for the sample output, we are getting the sample output. What did we miss? We have considered if it is greater, if x is greater and y is greater. And should we consider if x is odd and even and odd also? Yeah, what if x is odd? Here we haven't seen even and odd. Even we have just seen if the difference is greater than or equal to 2. Let's see if x percentage divided by 2 is not equal to 0. That means if it is odd and x is itself is greater than y, then we have who will be winning in this scenario. X is not even, but x is greater than y. If it is not even, can we subtract 2 from it to make x the winner? To not to make okay, we need to find the loser, right? Cannot make more losers, determine the winner if both players pay upload only. Okay, so we can remove, if it is odd, it will end up at 1 and he will lose, right? Chefina can remove 1 and 1 and he will lose. So Chefina will be the winner. And we'll also return here too many return statements. Ideally, it's not good to have so many exit points in your code. Okay, now we need to check else if x percentage divided by 2 is equal to 0 and x is also greater than y. In this case, we'll say chef will be winning and we'll return. Same, else if y percentage divided by 2 is equal to 0 and y is greater than x. In this case, obviously our chef is going to win. And I'll see if y divided by 2 is not equal to 0, that means y is an odd number. And if y is an odd number and y is greater than x, since it's an odd number, we can go with still 2. Since after Chefina, chef will be answering, so we can stop at 1 and then chef will take the lead. Since y is greater than x, he cannot do -1 I guess, and he cannot subtract 2, so he will lose, which makes Chefina the winner. And return. So let's just compile our code. The file name is 102. Let's copy. We got Chefina, and Chef, which is correct for the test cases that are visible, and for the hidden test cases. Yeah, it is the correct answer. Next, okay, we have solved 15 question in order of 1, that too in quite a bit of time. Shall we check the mountain question also? Let's check the rating. Rating is 2000 and the question is about the matrix. Okay, we are not going to solve that question after waste our time on such higher rated questions when our rating is just 400. So we'll go for practice and let's solve few array questions of moderate difficulty. Okay, let's go for parallel processing and equal max splitting. We know what is max actually. Let's solve the parallel processing first. So clear atom parallel processing. Okay, that is not the code. It is PLP ROCSS dot CPP. Here the question is, there are n tasks waiting in the line to be executed. The execution time for the ith task is AI seconds. Chef has two processors to execute these n tasks. Both these processors work simultaneously. Each processor executes the assigned task one by one. Chef assigns a prefix of these tasks to the first processor and the remaining tasks to the second processor. Okay. For example, if there are 3 tasks, Chef can do one of the following. Assign no task to the first processor. This means the second processor will execute task 1, 2 and 3. Assign task 1 to the first processor. This means the second processor will execute tasks 2 and 3. Assign tasks complete to the 1 to the first processor. The second processor will be doing task 3. And assign task 1 and 2 to the first processor. The second processor will execute no task. Find the minimum time in which all the tasks can be executed. Okay. Here they are given 4, 2 and 3. Then the explanation is, Chef assigns task 1 to the first processor and task 2 and 3 to the second processor. The first processor takes 4 seconds to execute task 1. The second processor will take 5 seconds to execute task 2 and 3. Thus at least 5 seconds are required to execute all tasks. Okay, 4 plus 2 plus, okay, we cannot add them. Chef assigns takes 1, 2, 3 to the first processor are executed by second processor. Or else we can do 6 and 1 by 1 processor, 7 seconds. 6, 1 and 2 by 1 processor, 6, 7, 8, 9 seconds. There 9 seconds here. Okay, for test case 2, okay, all the 3, 3, so you can divide it. So total 3 seconds. Chef assigns task 1 to the first processor, no task executed by the second processor. So we'll sort the array. We'll take the middle element and we'll add all those middle elements to the integer 1. Okay. So we'll take the array. We'll take as in the first, second variables. S will be equal to 0 and first will be equal to 0. Now we need to go and take less than or equal to n by 2 and I plus plus cn, sorry, it's not cn. Before that, let's sort the array. Sort of a plus n. Yeah, after sorting the array, we'll be having all the less numbers. In the front and all larger numbers in the end. Don't you think if it is 1, 2, 3, 4, 5, 6, then it is 3, 4, 5, 6 first processor will take 6 seconds, but the ROS processor will take 15 seconds. So if we say 1, 2, 3, 4, 5, 6, and if we have first one and the last one, if we add to the one processor, so it will, and this first one also, so 9 seconds here, and 5 plus 4 plus 3, 5 plus 4 plus 3 is 12, so it will take 12 seconds. So 6 plus 9, 15 seconds. Now the answer is 12. So the answer is reduced. We'll give 5 and 6 to first, 5, 6 and 1 to first processor, 2, 3, 4 to the second processor. So for 12 is one side, and 2, 3, 4 means 4, so 9 is one side. Same. Even if you give these two and the last one to one processor and the middle ones to the other processor, it is same. So after sorting, we'll go n less than n by 2, and we'll read we'll be just saying one in right, that is f plus equal to a of I. After that, from the middle element equal to n by 2 to I less than n minus 1 till the last element, add it to the second, or we'll take a for loop. We'll iterate from the start into n. Which one is small, we'll add to that one. For int I equal to 0, I less than n, I plus plus. Inside this, if f is less than s, if f is less than s, then f plus equal to a of I, else f plus, okay, else plus equal to a of I. That's it, right? After doing this, we'll also need to close this. Okay, after doing this, what do we need? We need an answer variable and a comparison between f and s. So if f is smaller, then the answer is s, and if s is smaller, then the answer is f, and we'll print the answer. And of course, shouldn't forget the new line. So let's compile people process and let's run them. Copy all the code. We got 6, 3 and 5. 4. So initially f is less than, okay, we'll add to the s, right? So a of I is 4. So since 2, 3, we need to get 5. Why is one number increased here? Since I is 0, f is also 0, s is also 0 initially. So f is less than s is false. So they will give it to the s processor, a of I. A of I in the sense 4 is given to the processor s now. It will take 4 seconds. And second processor will be given 2. And again it will give okay, s value is now 4. If this is true, so we'll add a of I is now 2, right? I mean 1, right? So for 1 indexing it is 1. So for 1, if we add we will be adding f is less than s, f is 0 and s is 4. So we'll add 2 to the f. Next we have 3. For 3, f is still less than s, so we'll add 3 to the f. That means we got 5 one side and 4 one side. Comparing 5 and 4, why did I get 6 as answer? This we are getting 6, 3 and 5. Actually, I'm so sorry. The time now is actually 12. So I'm feeling very tired. So today's session is just for half an hour. We actually solved two questions which we have partially solved yesterday. So I'll be adding those two questions to the Git, saying it is day 16, right? It is day 16. I'm so sorry, couldn't remember the day. Anyways, the code will be available in my repository. You can go through it, and please check out the previous video. I'll provide the link to the previous video, that is day 15 video, in the description. Thank you so much, and so sorry for stopping the session abruptly. Thank you.